Hello and welcome to Cloud Native London. This is your host, Cheryl Hung, and I am going to kick us off with a little bit of music. Really great to be back. I have been on maternity leave for a couple of months, so I'm thrilled to be back hosting Cloud Native London. If you're joining us on Twitch or YouTube, then thank you for joining us. You can also come and join on Rambly, which is our little platform where we can chat and hang out together as well. For now, just hang out for about 10 minutes. We're going to listen to some music together, get in the mood, get a drink, and we'll kick off at 7 p.m. UK time, which is in 12 minutes. So I will see you soon. Hi, this is Cheryl. We're about to kick off Cloud Native London in just a minute. Alrighty, hope that you have a drink and something you can sit back and relax and enjoy the rest of tonight's meetup, which is March of 2022. First of all, welcome to Cloud Native London. Who are we? We are a strong, open, diverse developer community around the cloud native platform and technologies in London, but of course, like everything else, virtual at the moment. We're hoping to go back to in-person events in the future. We'll see what time that happens. My name is Cheryl Hung. You can find me on Twitter at @OiCheryl. I'm currently an engineering manager at Apple. I've also previously been VP of Ecosystem at the Cloud Native Computing Foundation, and I'm very involved with all things cloud native. Tonight's meetup is going to follow the following agenda. Our first talk is going to be about load testing with F1 from Adelina and Andy. Then we'll have a second talk on improving your cloud infrastructure security with a maturity assessment framework from Arick. Then we'll take a 15-minute break and finish up with cloud native application development with Ballerina from Sameera. And that will be the end of this evening's meetup. I want to say thank you to tonight's sponsors. We have 3 sponsors. And I'd like to welcome them and have them tell them a little bit about themselves. So first up, we have David from Palo Alto Networks.
Thanks very much, Cheryl. Welcome back. Yes, Palo Alto Networks, or also Prisma Cloud as part of Palo Alto Networks. Thanks again for allowing us to continue sponsoring for another year the CNCF sessions. And really, what are we about? Well, we help customers understand vulnerabilities throughout the lifecycle, understand misconfigurations and things like Kubernetes YAML files, and then throughout the entire lifecycle. So whether it's in CI, registries, code repos, we'll take a look at it and hopefully fix it there and then. Or in runtime, we'll also look for anomalous behavior as well and help customers understand whether there's lateral movement or crypto mining or any other security issue in the running environment. Our strategy right now is very much around the supply chain. So we really want to help you understand how you can identify vulnerable packages and misconfigurations through the life cycle. And thanks to the fact that we can enforce what can actually run in the running container environment, we'll go ahead and stop it there for you as you wish, as per your policy. So yeah, me and my team happy to help. If you want to know more, feel free to find me on Twitter or LinkedIn, David J. McLean, and enjoy the rest of the evening. Thanks, y'all.
Brilliant. Thank you, David. And I say it's really lovely to see you again.
Likewise.
The other 2 sponsors actually couldn't make it tonight, so they've asked me to read a few sentences on their behalf. So first of all, let me talk about Circle CI. The world's best software teams use Circle CI to deliver high-quality code with confidence. As the largest CI/CD platform, Circle CI empowers engineers to seamlessly take ideas to execution at scale. Every feature of our platform is built to fine-tune the entire development process from start to finish. And then lastly, Sysdig. So Sysdig is driving the standard for cloud and container security. With Sysdig, you can prioritize software vulnerabilities, detect and respond to threats, and manage cloud configurations, permissions, and compliance. Your teams get a single view of risk from source to run with no blind spots, no noise, and no black boxes. So that's it. Again, thank you to all 3 of our sponsors. We wouldn't be able to run these meetups without them. So I'm thrilled that they're continuing to sponsor and support us and support the community. Now I want to find out a little bit about you. So if you are watching at home and you have a phone or laptop or tablet handy, please go to this link, oicheryl.com/p. this will send you to a service called Poll Everywhere, and this will allow me to ask you a couple of questions and we can answer and just find out a little bit more about each other. So I'm going to ask 3 questions about you and 2 questions about how you use Cloud Native. And I'm going to invite Adelina, Andy, and Sameera to come and just comment on the results as they come in. So please go to this link, oishow.com/p. So our first question is this your first time at Cloud Native London? So you can see people already answering. That you should see a yes and a no on your screen. Just hit yes or no if this is your first time or if this is the first time that you've joined. Looks like we are steadily 50-50. I saw a couple of yes was putting ahead for a moment. I'm going to give a few seconds because let people figure out how to join that. If you missed that link before, you can also use this slightly longer link to join. Okay, looks like it is holding steady at 50-50. Cool. Well, whether it's your first time or whether you're coming back, it's fantastic to have you here. Next question, where are you now? So you should see a world map. Just tap on wherever you are on the map. You should see some results coming in. Okay, I see a couple of people hanging out in the UK. This is always nice because you can see like people joining from all over the world. I mean, I'm not sure what this one is here. Someone joining from Alaska? Is that Alaska? Give a few more minutes for people to figure out where to join. Oh, I think this person might have changed to Canada. Okay, sweet. Always like this because when we're running things virtually, people do join from all over the world. Oh, someone else from the UK, someone else, can't quite tell where this one is. Somewhere in Europe. This is always a test of my geography and my knowledge of countries as well. I always feel like I should be revising what countries are on this world map before I start this. But either way, wherever you are, again, thrilled to have you joining and watching Cloud Native London. Third question, what is your job title? So just pick whatever job title is kind of closest to what you're doing at the moment. Your options are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And if it's anything else, then please use YouTube or Twitch chats to just introduce yourself and say where you're from and what you're doing. Looks like SRE and DevOps manager pool is putting ahead at 50%. Architects as well, hanging out, engineering managers, no application developers or backend developers today. All right. Okay, I think this seems to have settled. So now I'm going to go to the questions that were submitted from our speakers. And the first one of those is, which tool or library do you use for load testing? So Adelina and Andy, one of you submitted one of these questions, right? So what were you thinking when you asked about this question?
Hey, so we submitted it because we wanted to see what people are using. These tools, JMeter, K6, and Gatling, are some of the most popular ones. And today we will be talking about a tool that we wrote ourselves. So we wanted to see what people are familiar with.
Looks like JMeter seems to be the most popular. Oh, you know what isn't here? There is no answer for no load testing. Do you think that a lot of people are using load testing tools now?
I think if you're running things in production, you know better than to not load test.
Well, you should, right? But there's always a lot of, what you should do versus what people really do. So I'm curious, what do you see when you ask people? Is this what you expected?
I expected, to be honest, I thought K6 would be more popular than JMeter. But yeah, we'll talk a little bit more about why I thought that.
Okay.
During the talk.
Awesome. Andy, do you have anything else? Anything you want to comment?
Yeah, I also thought K6 would be more popular. Certainly in our research, that was sort of the preferable tool, and we used it for a long time. So it's interesting that no one has said that they use it. That's interesting.
No one yet, but you may find out others yet.
And I expect the 20% people using other tools are probably using the tool we're going to present today. So that's encouraging. Yeah.
Sweet. Alrighty. I don't know if you have Arick on the line at the moment, but this question was, is public cloud security a priority for your organization over the next year? So your options are high, medium, low, or not a priority. Adelina, Andy, or Sameera, I'd love to sort of get your thoughts on this. Sameera, maybe, I know this is not your question, but what do you think?
I think it's answer is, to me, as obvious. It's a high priority in at least the work we do in my company.
I'm always curious about this because, you know, obviously it should be high priority, but then what does that really mean for your organization? Like, what do you see, Sameera, that makes it a high priority?
So so in my company, we provide, basically we have a cloud platform that we provide for people to come and deploy their applications, integrations. So we want to make sure maximum security for those applications, and we want to provide capability so that other people come and secure their applications.
So do people tell you the same thing, that public cloud security is high priority for them? Like when you talk to people, do people say the same to you, that security is an issue that comes up for them?
Yeah, definitely.
I think everybody, yeah, well, at least everybody's in agreement here that it is a high priority, so that's good. No one says no, security is not a priority. So yeah, we'll see what that means. I'm looking forward to learning a bit about Ballerina as well. I've been watching it for a little while. And I think that is it for me. So I'm going to hand over now to Adelina and Andy. Well, Adelina actually first. Again, I want to say thank you to our speakers for joining us tonight. And Adelina, whenever you're ready. I don't hear you, Adelina. You might be on mute.
Yeah, I was on mute, sorry. Hello, everyone. Thanks for having us today at Cloud Native London. I'm here with my colleague Andy to tell you all about testing asynchronous systems. It's our first time speaking at Cloud Native London, and we're very, very excited. Andy and I work at Form3. We are a B2B payments technology provider, and we work with some great customers, as you can see on this slide. Our code base is fully Go, and we have around 260 employees. We work fully remote. And so everything we do is with the remote first mindset. Now, today, I'm going to talk you through some performance testing fundamentals, very short introduction. And then we're going to talk about some common tools that you could use to do your load testing. Then I'm going to hand over to Andy, who will tell you about our tool, which is called F1. And he will make you a live demo with a little bit of live coding. Who doesn't like a live demo and live coding, right? So, without further ado, let's dive into the world of performance testing. So, performance testing checks the behavior of your and performance, that's why it's called performance testing, of your system. It examines the stability, scalability, and reliability of your system. It tells you whether your system behaves correctly according to your business needs. And it might be interesting to performance test your system according to not only your current volume, but what you expect your volume to be in the future as well, to tell you where your bottlenecks and how much runway you have for your system. And it is very important for a high volume payments platform like ours. Now, under the umbrella of performance testing, we can look at 3 types of sub-tests, and these are load, spike, and soak tests. Load testing tells you how many concurrent users or transactions your system can handle. And you should test not only one load testing scenarios, but different, because you will use resources in different ways. Now, load tests should be performed all the time to make sure that your system is performing correctly as you continue to change it. And that is why it should be integrated into your CI pipelines. When it comes to load testing, we said that you could see how many users your system could handle. But stress testing is a performance test that checks the limits of your system under extreme loads. And when it comes to stress testing, you have spike and soak testing. So spike testing is when your system is subjected to very quickly ramped up extreme load, while soak testing involves slowly ramping up the load and checking the stability of your system. And stress testing checks for memory leaks, data corruption, and a whole other host of problems, not just the scalability of your system. And when it comes to stress testing, you should perform it before special events, like, for example, Black Friday, if you're a retailer. Now, before you performance test, it is also important that you have the correct monitoring in place to be able to tell what exactly is a pass or a fail. And we've left on this slide some good metrics that you should monitor and alert on before you start performance testing. And these could be average response time as well as peak response time, error rates, and CPU usage. This should be in place before you begin to talk about performance testing. You need to know exactly when we're talking about a failure. Now, at Form 3, our systems make use of events and asynchronous requests, exactly like what we see here. And this is the example application that we'll be looking at today. So it's very, very simple. We have a service that exposes a payments endpoint, and then it does some background processing. And once it's finished, it outputs the response to an SQS queue. So what we need to do is we need to have a way of connecting requests to their corresponding result in the SQS queue. Once we send a request, the service will respond with a 202 accepted. And if we think that that's the response, then it'll seem like the request completed immediately. And F1 is our open source solution that we will be talking about today that will help you achieve just that. Okay, so now that we have the fundamentals of performance testing in place, let's talk about some common tools. And these relate back to the poll that we submitted to you. First off, there's JMeter. And JMeter was the winner in our poll. And it is an open source Java testing tool that can be used for load testing. Test plans are configured using a recording GUI and templates. And for async testing support, which is what's important for us and what we'll be looking at today, we can use long polling or another request to see when a request is completed. We can configure a number of threads underneath, and then we can set up a ramp-up period in seconds for the load specification. JMeter also offers plugins for step and spike ramp up, even though they are not supported natively by the application. Next up, we've got K6, which is also very, very popular. It is an open source Go project run by Grafana, which is used for testing API endpoints. And tests are configured using a scripting language similar to JavaScript. At the end of the test, you'll get a small report, but it also supports integration with, for example, Datadog or InfluxDB. We configure the load test using an options object, which states how many requests are run, and this allows us for a linear ramp up of requests. And K6 does not provide support for any promises or asynchronous execution, but we can achieve the async testing using virtual users. Now, at Forum 3, we invest a lot of engineering time in performance testing our platform. As we've discussed, it's very, very important. And we initially used K6 to develop and run these tests, but it didn't fit our ideal load testing tool. So for us, our load testing tool should allow us to write asynchronous tests that are easy to integrate with our SQS queues. And this is not always the case with JavaScript. It should also allow our engineers to write tests in Go, because this is how our platform is written, and it's also the easiest way we can integrate tests with our CI pipelines. And finally, our platform operates under huge amounts of load, so the tool should allow us to run different modes of load. As you can see, the existing solutions did not provide us with these features, so this is why we decided to write our own solution. I will now hand over to Andy, who will tell you all about it.
Thanks, Adelina. Yeah, so let me share my screen. I should be able to show a slide. So let me introduce F1, our load testing tool that we wrote. We chose the name F1 because it's got F in the name for Form 3, and F1 sounds like a really fast, thing, which load testing should be. Yeah, it's an open source tool. Initially, it was an internal tool, but we decided to make it open source because it's pretty general purpose. And it has two main features, basically. The first feature is that you can write your test cases in Go. We were using K6 for quite some time, using sort of a weird combination of JavaScript and Go, but the ability to write test cases natively in Go was something that we were really after. And as Adelina mentioned, it also allows us to run load in a variety of different modes, which I'll probably be able to demonstrate more at the end of the talk. But we were constrained somewhat by the ways that K6 allows you to inject load into your system. We needed more flexibility. So let's go straight into a demo. What I'm going to take you through is basically an example application, which is available online on GitHub. So if you go to the GitHub organization Form 3 Tech OSS, you'll find F1 there, but you'll also find this this example app I'm going to take you through. So I've got a an empty directory here. What I'm going to do is I'm going to try and model the software systems that we test, and then I'm going to write some simple load tests and demonstrate how F1 can be used to run those load tests. So let's start off with a Docker Compose file. So this Docker Compose file basically has a local mock-in for SQS. So there's this service called Go AWS, which provides an SQS compatible API, and it can be used to sort of mock real SQS queues locally. And I'm also going to run there like a fake service. So you see the service is empty. So let's also do some configuration. So I'm going to configure Go AWS using a config file. So if I show this config file, I'm basically just configuring Go AWS to expose a single queue called test queue. And I'm also going to add a Docker file for my test application. So there you go. I'm basically going to build an application using Go with an entry point in this directory command service main. And so what remains is for me to stub out an entry point for the application. So I'm going to make a directory to put that entry point in. I'm going to stub out I'm going to stub out some code for that. Let me and I'm going to initialize a Go module, which basically just lets us manage dependencies in Go. So now if I look in this directory, I've got an entry point file with nothing in. So at the moment, if I ran Docker Compose up, I'd get like an empty application running and an SQS mock in the background. So let's go ahead and edit this file. So first of all, let's get rid of this this empty main function, and let's put in an HTTP handler. So what I've got here is I've got my main function, which is going to handle HTTP requests come in on this relative URL /payments, and I'm going to listen for requests on port 8080. And the only thing my HTTP handler is going to do is return status accepted, so 202. So this sort of models the way our system works, where customers send payments to us, and we respond immediately with an HTTP response, and we kick off some asynchronous processing in the background. And the output of that asynchronous processing is observable by consuming message queues. So let's add some message queues to our application as well. So I'm just going to add some global variables for storing an SQS client. I'm also going to initialize that SQS client to use my local mock of Go AWS. And I'm going to do that before I initialize my HTTP listener. So what have I got here? I've basically configured my application to use my local SQS mock. I'm using some dummy credentials, and I've told it about the queue name that I'm going to be using, test queue, which is that one I configured in the Go AWS config file. So there you go. My application is ready to consume those SQS services. So the final thing I need to do is flesh out this HTTP handler, so that when I receive a web request, I don't just return accepted, I also publish an SQS message. So let's look at what I've got there. So here I'm saying, okay, if it's not a post request, I'm not going to handle it. If it was a post request, I'm just going to write out a log message. And then what I'm going to do is publish an SQS message. So in real life, you can imagine there's like a whole processing pipeline of asynchronous activity. But in this sort of model scenario, I'm just publishing an SQS message. And that's the asynchronous feedback that my load testing tool needs to consume. Okay, so we should have a functioning application there. So I'm just going to download all the dependencies that my application needs. And then we're going to try and run it and see what happens. So I can do this manually to begin with to demonstrate that it's working. And then we can think about writing a load test using F1, which will, exercise this behavior in an automated way. So any minute now, my internet connection. Yeah, there we go. So if I run my Docker Compose file in the background, and then have a look at what I've got running. So I've got 2 containers running. I've got my Go AWS container, and I've got my example service. So my example service was running on port 8080. So if I now try making a web request to localhost 8080, what do I get? So I get a 202 accepted, so that's good. Now maybe I'll have a look at SQS. So first of all, I can just check that my queue exists. I'm using the AWS CLI here, but I've configured it to use Go AWS instead. So my queue's there. And if I look at the attributes of that queue, there's one message visible in that queue. So if I make another web request, I get another 202. And then if I have a look again, now there's two messages visible in that queue. So making my web requests is publishing messages to that queue. So my application is working as expected. Okay, so now let's stub out a new F1 load testing command line interface. So what I've done here is I've made a directory, an entry point called F1. And similar to before, I've just stubbed out an entry point file. So let's edit that. Okay, so this is what you would do if you wanted to write load tests using F1. So the first thing I'm going to do is I'm going to import F1. And then I'm going to instantiate a new instance of the F1 command line interface here. And that's almost it, almost. So now if I download my F1 package dependency, what those two lines of code have done, they've provided me with a fully fledged command line interface for F1. So if I run that entry point now, and I just put -- help on the end, I'll get the command line help that the F1 command line runner provides you with. So you get sort of a fully fledged command line interface. It's not normally this slow. It's not good for a load testing tool to be slow and giving you help. There we go, right. So you can see here, I've got all of the sort of commands the F1 CLI provides you with. But anyway, let's go back to writing a load test. So what I need to do is I need to register load test scenarios with F1. And I can do that easily using the F1 Go API. So I'm going to register a new scenario. And what does a scenario look like? Well, a scenario is basically a function. Oops. What's happened there? There we go. It's basically a scenario, a function that looks like this. So this is a function with some code that gets executed one time as sort of setup, which then returns another function, which is invoked every time F1 runs a test iteration. So if you're running like 100 test iterations a second, this function that gets returned is invoked 100 times a second. So at the moment, our test scenario doesn't actually do anything. So let's configure it to be able to use SQS. So this is sort of similar code to what I had in my HTTP service. So what have I got here? I'm again configuring the AWS client to use my local Go AWS service. Got some dummy credentials, and I'm getting the queue URL for my test queue. And this is where writing the tests in Go starts to become really powerful, because I can make use of all of the asynchronous and multi-threaded primitives that Go offers. So what I'm also going to do now here, before I start running any sort of test iterations, is I'm going to start consuming messages from the SQS queue. So what I'm doing here is I'm creating a channel in Go, which is like a thread-safe in-memory queue. and I'm running a Go routine, which is like a background thread. And in that background thread, I'm going to start polling SQS, receiving messages from SQS, and putting them into this messages channel. So in the background, when my tests are running, there's now an in-memory queue that's being hydrated with messages from SQS. So now we're ready to write our actual test iteration implementation. And that basically needs to do exactly what I was doing using curl earlier. It needs to publish, it needs to make web requests, make post web requests, and then consume SQS messages. So let's do that. So yeah, here's one I prepared earlier. So what does this function do? Makes a post request to my HTTP endpoint, checks that it returned a 202, which is what we did with curl. And then it waits for up to 10 seconds for an SQS message to be received. Now, there's no logic here that sort of stitches together the web request with the SQS message. Obviously, you could write logic that did that if you wanted. All this really does at this stage is it checks that an SQS message was published in response to the HTTP request being sent. And you know, as simple as that might sound, it was really difficult to do that using K6 because JavaScript sort of is not really the right language to support these sort of asynchronous flows. Okay, so I have written my first F1 load test. So let's just compile that binary now to make running it a little bit more user-friendly. So I'm going to compile it into a binary called F1, which will give me a command line interface that I can use. So first of all, I can run F1 scenarios ls, and I should get a list of the scenarios that I've registered in this CLI now. So my test scenarios there. My applications should still be running in the background. Yeah, so I've still got SQS and my service that I want to test. So now let's go ahead and run some load. So what I'm doing here is I'm running load using one of F1's built-in sort of runner modes, which is called constant. And what that does is it runs load at a constant rate that you specify. So this is running load at a rate of 1 request per second or 1 test iteration per second for 10 seconds. And I can obviously adjust that. So I could say, okay, I want to run 10 requests per second or 10 transactions per second. And F1 will endeavor to do exactly what you ask it to do. So it will try and do no more and no less than 10 iterations per second. And you can see we get some like basic output here, instrumenting how quickly those end-to-end transactions are taking. And that's how long it takes from us making the web request to us consuming the SQS message. So we're not just timing the sort of synchronous HTTP request. So this running mode of like running constant load isn't really supported in tools like K6. You can sort of tweak the command line arguments to get something close. But really, tools like K6 offer you the ability to run load using a pool of virtual users. F1 supports that too. So F1 also has this users mode. And in this users mode, what I'm doing is I'm using 10 virtual users. And those users are each making requests consecutively. So you see, you get a very different result here. Like instead of having 1 or 10 iterations per second, we're now getting like upwards of 200. And this, I guess, just illustrates some of the flexibility that F1 brings to the table. These are like 2 modes for running load. It supports a few others as well. And what we wanted to do really was build in the flexibility to run load in lots of different creative ways, which we weren't really able to do with these other load testing tools. So that is that's the demo over. That went reasonably well for a live demo. See if I can go back to PowerPoint. So yeah, there you go. There's the URL. It's on GitHub if you want to see that again. So where does that leave us basically? So I said this at the beginning. load testing is important. It's especially important for us because we run a highly available payments platform, and payments could come in any time from a pool of millions of users, the general public, and we need to be able to service those requests. So we run load testing in all of our pre-production environments to make sure any load-related problems are sort of caught early, and we use F1 for that. So F1 is sort of the pillar of our load testing endeavors, it's sort of in active use every day. I don't know of anyone else using F1, even though I was sort of hopeful that people that voted other were, but we thought we'd share the good news with the wider community. So that's us. Find out more about Form 3, check us out. Otherwise, I guess we've got a few minutes for questions.
Brilliant. Thank you so much, Adelina and Andy. I'm going to pop the questions back on the screen for a moment. So if you have any questions for Adelina and Andy, then please use that link before or this link to submit some questions. I'm curious, I saw you open sourced this F1 tool. So what is your goal? Are you trying to get people to use F1, or do you want people to contribute?
Yeah, we don't really have an agenda there. I mean, we wrote it originally as an internal tool, and then we realized it was pretty agnostic about Form 3 technology. So it was very little effort for us to open source it. We're not trying to promote it necessarily, but we just want to share the good news, because from our point of view, it's we would say this, but it's a much better tool than the other tools we tried in the market. So we're just sharing the good news, really.
Nice. I like it. I appreciate that you just want to share what you've done.
Yeah, and it's huge to be able to use coroutines and channels for your tests. It's a lot of flexibility.
We are basically on to the next slot, unfortunately. I don't know if people are in the middle of submitting questions, but what is the best way to get hold of you? Is it through Twitter if they have following questions?
Yeah, so you can write to us on Twitter, or you can write to Form3 Tech handle, and we'll write back to you as well, because that is like our Form3 engineering account. That's maybe easier to remember. But it's been a pleasure, and thanks for having us.
Thank you both. I found this really interesting. Let me stop this share. And Andy, Adelina, thank you so much. Now I would like to welcome our second speaker. We have Arick on the line. Hi.
Hi, Cheryl. Hi, everyone. Thanks for having me today.
Hi, thank you for joining. Please feel free to share your screen, and it's all yours.
Absolutely. Is it sharing all right?
Looks good.
Perfect, perfect. So nice to meet everyone. My name is Arick Goomanovsky. I'm one of the co-founders and the chief business officer at Ermetic. Ermetic basically is a cloud security solution. We help organizations that are utilizing public cloud infrastructure environments, the Amazon Web Services, AWS, or Microsoft Azure, or the Google Cloud Platform. And we work with those customers to help them secure those environments. We work with a range of companies, starting from traditional Fortune 10 enterprises that were on-prem forever and ever, and have recently started migrating workloads to public cloud infrastructure, and all the way down to cloud-native, cloud-born companies that have been created in the past 10 years, never had anything on-prem. Started from having their first workload in AWS or GCP or Azure, and they're very proficient in cloud infrastructure and cloud security in general, utilizing the vast variety of cloud services, and having challenges as they scale up to better protect their cloud infrastructures. Now, we've been working with organizations for a long time, hundreds of companies, and we have, in our effort, helping organizations better secure their infrastructure, we understood that there is a piece that is really missing today, and that organizations really need. And that's something that would basically help them understand where they are in their cloud security maturity. And we really think this is the missing piece of the puzzle in organizations' cloud security strategy. And this is something that we wanted to take the opportunity to talk to you team today, because we thought that this is a topic that combines both technical elements, but also more kind of high-level strategic elements when you're thinking about cloud security. And we thought that that could be a good topic and could apply to a broader audience. Okay, so let's talk a little bit about the challenges with cloud infrastructure security that we see out there, right? And again, we'll try to keep that at a very high level. Of course, behind every bullet point here, we can double click and detail a lot of different challenges, both technical, but also process-wise and so on and so forth. But again, we'll try to highlight the key elements. First of all, it's not a one-size-fits-all exercise, right? As I was saying, we have, we work with different customers, and something that might apply to a cloud native company does not apply to an organization that still has a lot of workloads on-prem and has a hybrid environment, right? It also depends on type of resources that you're using the cloud infrastructure for, whether you're storing your sensitive data there, whether you're storing your compute resources, and so on and so forth, right? So it really has to be to some extent tailored to the organization, to the vertical, to the size, to the nature of the business, to the nature of what the purpose they're using their cloud infrastructure for. So I think that's pretty obvious. In addition to that, cloud security is extremely multidimensional and complex, right? The organization might have one cloud infrastructure and using a variety of services. So for example, if we're looking at Amazon, they're offering close to 300 services today, right? That's a lot of things to consider, a lot of complexity around that. Of course, if you have a multi-cloud environment, it increases, probably goes to the square or to the third power of that, right? Complexity. In addition to that, the cloud environments are extremely dynamic. They're way more dynamic than we used to have our environments on-prem. And frankly, this is one of the core business reasons people are going to the cloud, right? Because they can scale up and scale down those environments very effectively, right? And the cost is manageable, right? So that's one of the core business reasons why organizations are going to the cloud, and they're leveraging that more and more and more and more. On top of that, you have to remember that cloud security requires specific knowledge. You have to be proficient in the cloud infrastructure, which is something new. So we don't have a ton of people that have that expertise. And organizations really struggle with finding that talent because of the scarcity of of security talent overall. And when you kind of looking for a cloud security engineer today, you're basically looking for a unicorn, right? And unicorns are very difficult to find. On top of that, let's say you're in an organization that has been using AWS forever and ever, and you have built proficiency in AWS security. And now for some business reason, you go and you acquire another company, and that company is running on GCP. And now you have inherited their GCP environment with all that complexity, and you have to secure that as well. But you don't have any GCP security understanding. So that adds an additional layer of complexity. The requirement for specific knowledge is a big gap many organizations are facing. And ultimately, when we're talking about cloud security, we see that in organizations in general, many people are involved. If you think about the on-prem environment, right, your on-prem data center, you would have the security team working together with the IT, who would have the responsibility for the data center. And a lot of things you could have closed in a short loop within the security IT organization. When you talk about public cloud infrastructure, in many cases, the infrastructure itself is not owned by the IT anymore, and definitely not by the security team. It's often owned by cloud operations teams, DevOps teams, and in many cases, just by the developers and product teams. Therefore, the number of stakeholders who are responsible for this combined effort of cloud security is significantly increased, right? And you have to take a lot of people with you. So that's why we think that when you're talking about growth in terms of your cloud security maturity, that process has to be well guided and well synchronized, right? So you need something to help you in that process. And it's a process. It's not just a one single bound, right? That it requires a lot of continuous effort. And when you're looking at what the industry has to offer us, you look at the body of knowledge that the industry has. So for example, if you look at the Cloud Security Alliance Enterprise Architecture reference diagram, it's extremely complex. And if you look at that chart, right, it's just a reference for a 90 pages document, which is also by itself is nothing more than a reference to a much longer document, right? So if you're trying to think of, okay, how I'm going to build my cloud security maturity roadmap, how I'm going to build my strategy, where am I today, right? How can I assess where am I today against that strategy? All that is extremely, extremely complex, right? And if you're trying to use the bodies of knowledge that the industry offers today, basically you're going to be disappointed. And that's why we identified that as kind of the missing piece of the puzzle, right? There are great technologies out there, but actually how I'm going to apply those technologies to make sure that I'm in a good spot in terms of my maturity, how I'm going to build a strategy around improving my maturity, that's something that we see organizations are really, really struggling with. And that's why we at Ermetic decided to build something that we call Cloud Infrastructure Security Maturity Model that is going to be lightweight, right? Something that is way, way easier than this complex picture. Something that is approachable, that anyone can use, right? And you don't have to be an AWS security guru to understand and assess where your organization is and what you have to do to improve. And something that's going to be effective, that really will help you improve, right? And that's what we've been building over the past few months. And again, that cloud security maturity covers a number of domains. First of all, from the technology perspective, it covers the visibility you have into your cloud infrastructure today, your ability to prevent risks or basically prevent potential breaches or minimize the blast radius of a potential breach on the preventive side, but also the ability to detect threats in your environment, right? These are kind of the domains we're covering from the technology perspective. But you have to remember then when you're thinking about strategy and your cloud security strategy, technology is not all there is, right? You have to think about the organizational perspectives as well. And here the two critical domains are people, what people you have, how they're trained, and so on and so forth, how they're organized, and also what are the processes you have within your organization that actually support those people and utilize those technologies that you have decided to implement, right? And our cloud security maturity model basically looks across those domains and help you understand your current position. Now, to help you understand or to help organizations understand where they are, we've introduced a number of very simple levels of maturity, starting from ad hoc. Ad hoc, as it sounds, means that people are not really doing security. They're doing security ad hoc. They're doing security when they're doing security, but it's not top of mind. There is no designated effort around security. Maybe they're doing something sporadic once in a while. They don't necessarily have a designated security team. Security is an afterthought. Basically addressing issues when things blow up, right? That's basically where most organizations start off in the beginning. Then on top of that, we have something that we call an opportunistic level of maturity. This is exactly when an enterprise starts to think about cloud security and address cloud security in a structured way, and having some kind of a strategy and that is incorporated into its strategic roadmap, right? That's the second layer. The third layer is actually when an organization really already has a pretty mature level. They understand that they need to execute on their cloud security strategy, and they're doing that periodically. They're doing that in a repeatable way. So for example, You have a strategy, you're working on the strategy, something changes in your environment. For example, you go out and you do an M&A and you acquire another company, that's a good point to repeat that process and start it over again, or to adjust your roadmap and adjust your strategy based on those feedbacks. You're changing your product, right? You're adopting new cloud services. Okay, maybe you should rethink and reconsider and reiterate the process. Or maybe you just should do that reevaluation periodically, every month, every week, and so on and so forth. But you have a strategy, you have a team, you have tools in place, you have processes, and you're periodically assessing your capabilities and identifying gaps and acting on those gaps. And ultimately, there is the top layer, which we call automated and integrated. This is the higher level. That's when the enterprise has enforcement of most of the significant components of the cloud security strategy, and they apply them automatically. There is full integration of the team. There are automated processes in place, and cloud security is integrated deeply into the organizational DNA. All right, so these are the the very basics, very simple maturity levels, and to understand where you are against those maturity level, right? Basically, we've introduced a very simple framework. Again, we're looking at the people perspective, the team perspective of that maturity model. Again, there we'll look at roles and responsibility, basically how the team is structured, and training, how the team is trained, what capabilities the team has. We'll look at processes. We'll look at your remediation processes. We'll look at integration into your CI/CD processes. We'll look at compliance, access governance, and incident response processes in the organization. And we can tell you where you are against those basic levels. And same from a technology perspective. As we mentioned, we'll look at visibility, the ability to manage inventory, and to contextualize that visibility. So for example, not only saying, hey, I have a database here, and these are the people who has access to that database, but also saying, hey, this database has sensitive information, and the sensitive information should be subject to a specific compliance framework, and so on and so forth. So bringing the context into the visibility side, looking at the preventive capabilities across the technical stack, identities, permissions, data resources, compute resources, serverless resources, basically cloud workloads, so servers or virtual machines, containers, and container orchestrators like Kubernetes, serverless like Lambda functions, and so on and so forth. And of course, network access and network configurations. So being able to identify risk across the stack and potential remediate misconfigurations, prevent breaches, and minimize blast radius. And then around detection, we're evaluating the ability of the organization to collect interesting and insightful logs, and then to analyze and process those logs effectively so that the organization can detect potential threats and also run effective investigations, forensics, and triage activities, right? So all these are basically mapped out. And for each level, we have something that we call an indicator of matriculation, right? And the idea behind those indicators are, these are very short points that tell you exactly where you are in terms of your maturity. And again, we have put a lot of thought in identifying those indicators, because those indicators have to signify something that is very important for your organization, right? So they're not necessarily KPIs, but they're very strong indicators where your organization is, right? And a great example for an indicator like that is, the fly to the moon story, right? So again, recently, there was a research done by NASA where they said, look, the moon mission basically, it was hard, but it basically had a lot of benefits to the world of technology overall, right? So it's this. You can look at the moon mission, at the first moon mission, and the consecutive moon missions as exactly those indicators of matriculation, right? It's a target you set, right? And when you get to the target, it tells a lot about your level of maturity, right? So when JFK back in 1962 set that target, right, and that target was achieved 7 years later, the fact that this target was achieved, and again, putting conspiracy theories aside, that told a lot about the maturity of, for example, in this case, the U.S. Rocket abilities, the U.S. Navigation abilities, the U.S. communication abilities, and so on and so forth. And it all was represented by a single indicator of matriculation, which is the moon landing, right? So we have tried to do similar work and identify similar indicators of matriculations, and something that is very easy to understand if you have that or you don't have that, and has a lot of meaning. Again, let's look at some examples. So we're now looking at the processes part. Within the processes part, right? You remember, if we go back to the maturity model and we look at processes, one of the axes we're looking here is the remediation processes, the remediation capabilities. So let's look at that part. So we're gonna see what the indicators of matriculation are for ad hoc, opportunistic, repeatable, or automated and integrated levels of maturity. So ad hoc, you do not have any structured remediation processes for cloud misconfigurations of vulnerabilities. There is a best effort, right? You identify vulnerability and you resolve that when you have time, when you get to it. And if you don't get to it, you just don't do anything, right? This is the ad hoc level. The next level is when you have a security team that owns and prioritizes security findings, right? It's just one sentence, but it tells a lot. It tells that you have a security team, that security team has ownership over identifying security issues in your cloud infrastructure. They can prioritize security findings, meaning that they have the ability to prioritize security findings, and they own, right, those findings. So that's how we interpret those those indicators into a lot of meaningful, very meaningful elements beside them that talk to the maturity, to your maturity model. The next level, around the repeatable level of maturity, is when those prioritized findings are automatically shared with stakeholders, right? So we talked about the fact that there are a lot of different stakeholders that are involved in your cloud security maturity model, right, or program, right? It's not only about again, for example, only the security team, right? There are developers, DevOps, cloud operations teams, right? So let's say you have identified some cloud risks and misconfigurations or threats in your environment. Now you have to communicate to those teams so they go and actually act on that, right? So to do that, you have to be able to take those prioritized findings and share those findings with the relevant stakeholders, right? Not general stakeholders, but the relevant findings should get to the relevant stakeholders, and they should get there automatically. So for example, that implies that you have the ability to take your security tool, integrate that with some notification system like Slack, like Splunk, like Jira, and post the relevant findings to the relevant Jira boards automatically, right? So that tells a lot about your maturity as an organization, but also about the maturity of your technological stack that helps you to achieve that level of maturity. And then the last bit is, again, that's when we're looking at the highest level, is, for example, when those R&D teams that are actually responsible for the actual cloud infrastructure, they have the full ownership of resolution of issues. And that means a lot, right? That means that the R&D team is aware of cloud security requirements, that they have probably gone through training in cloud security, and that they have the know-how how to go and remediate those risks when they're getting those findings, and they're getting those findings automatically, right? So that that indicator tells a lot about where the organization is, right? And you can see how that is actually aligned to the maturity layers of other axes. For example, when you're talking about the team element, right? You remember at the people side, we had R&R and we had training, and you can see how well those are aligned. So, for example, if you have best efforts for or with no structured processes, there are probably no dedicated trainings and expertise in cloud security, and there is no dedicated personnel. When you have a security team that owns that, that means that there is some knowledge and responsibility within the security team for cloud security, and some members of the cloud security security team undergo cloud security trainings, because otherwise they cannot own the cloud security findings, and so on and so forth. And when you're getting to full ownership of R&D teams, it means that there are additional expert delegates to cloud security within the R&D teams. Otherwise, the R&D teams will not be able to own anything, basically. And there is cloud security awareness training program for the R&D teams, right? So you can see how well those indicators are aligned across the various levels of maturity, right? And we have put a lot of thought in the way we actually build that maturity program. Okay, so let's talk about a little bit about the effort, the values of that cloud security maturity. First of all, it allows you to synchronize your efforts in very effective measures, right? So you know what you have to do when you want to go and leapfrog, let's say, from an opportunistic to a repeatable level of maturity, right? It helps you design reachable, practical, and very clear milestones, right? You understand that if you want to go from a repeatable to the top level of maturity, you now have to engage your R&D teams, you have to train R&D teams in cloud security, and you have to establish delegates or champions for cloud security within the R&D organization, for example. It provides a collaborative language between stakeholders. So it's not only the security team that knows what they have to do, but also the R&D and the DevOps and the cloud operations teams know what is required and expected of them. And it does not create, again, you don't have massive document of 90 pages that is a reference to another 200 pages, but you have something lightweight and a really approachable compass you can work with to understand where you are. Now, how do you operationalize that model within your organization, right? First of all, you assess, and we in addition to that model, we have built a lightweight questionnaire that you can go through and see exactly where you are across the different domains and across the different levels of maturity to understand your situation, both from a people's perspective, a process perspective, and a technology perspective. After you've done your assessment, you understand what the gaps are, you understand what has to be done to get to the next level and to the next level, and you can start setting milestones and building an effective roadmap. And you can start evaluating various technological solutions that really address the challenges that you have at your maturity level, right? Because if you have a security team that really understands cloud security issues, probably there is very little point in buying a very advanced, sophisticated cloud security platform, right? Because you will not be able to operationalize that within your organization, right? So maybe first you should get the first personnel, you should train them, and then get them the tool that is aligned to their maturity level, right? So that's very important. And ultimately, you have to repeat it. You have to repeat it because your organization is growing, because your infrastructure is changing, because your team is maturing and changing, and so on and so forth. So maybe the tool that they need today is not the tool that they're going to need 2 or 3 years down the road, right? And that's something that you have to remember as well. And again, you have to remember a few things. Cybersecurity is a process. It's not an event. And same for cloud security, right? It's not a one-off exercise. You have to do that continuously over and over and over again. Maturity level is a commitment. It's not a certification. The fact that you are today at a repeatable level of maturity doesn't mean that, hey, I'm certified, I'm good to go. No, that means that there are a lot of things that you have to do and to stay the course, right? And to stay at the same level of maturity. And if you want to go one level above, there are a lot of efforts you have to go through, and you have to be committed to that, both personally as a leader, as a technologist, but also as an organization. And last thing that is important to remember, simple does not mean easy. we've built a simple compass that you can use to understand where you are and what you have to do if you want to go north, right? But it doesn't mean that the journey is going to be easy. And to make it easier, you need the right tooling, right? And this is exactly where we as Ermetic come into play as a company that supports organizations, not only in helping them understand where they should be going, but also with providing them the tooling to make that road easier for them, right? So basically what we offer in Ermetic is a public cloud infrastructure platform that helps you automate your cloud infrastructure security. In Gartner terms, we offer a combination of what is called CSPM, Cloud Security Posture Management Tool, and CIM, Cloud Infrastructure Entitlement Management Tool, that focuses on specific areas and elements in cloud security around identities, entitlement and permissions, activities, and so on and so forth. And that unique combination of technologies allows us to provide a full range of capabilities, starting from full visibility to your inventory around you, to scan your environment, get visibility, run some smart searches and queries, help you prevent risk. Again, that's talking to the prevention capabilities on the technology domain, right? Across the stack, looking at your identities, data, network workloads, detecting all misconfigurations, public exposure, helping you contextualize risk and prioritize it's properly. Detection capabilities, again, speaking to the detection element in the technical stack, full visibility into the activities in cloud environment, behavioral analytics and anomaly detection, and so on and so forth, remediation capabilities, and all that covered with governance and compliance. And again, the idea here is to make your cloud security and help you implement your cloud security strategy in a very easy and approachable way. I think we're against the hour, so I would love to pause here. Thank you so much for having us today. Feel free to contact me at arick@ermetic.com, or just on our website. All the information is there, and we would be happy to engage with you, help you understand what's your cloud security maturity is today, and guide you engage you in the dialogue and understand and help you understand where you should be investing to get to the next level of your cloud security maturity. Thank you so much.
Thank you, Arick. This is super interesting. I can really see the importance that it would have to so many different organizations. Maybe someday I'd love to chat about how you actually came up with this cloud native security model and how, like, the maturity model. And I think it'd be really interesting to hear about your process, how you actually came up with the model in the first place. But thank you so much for sharing it with us. We are out of time for questions now, but you already told people how to reach you, so that's great. Again, thank you so much, Arick.
Sure, absolutely. Thank you for having me, and good luck.
All right, we are going to go to a quick 15-minute break now. And when we come back, we will hear from Sameera. So in the meantime, please kick back, grab a drink, maybe grab some pizza, and I will see you in 15 minutes. All right, we are ready to get going again. So I hope you've got a drink or something to just chill out and relax. And now we are going to welcome Sameera. So Sameera, over to you.
Thank you, Cheryl. Thank you for having us. And thank you for the opportunity to talk about Ballerina. I'll share my screen.
Go ahead.
All right. Hello, everyone. So I'm Sameera Jayasoma. I'm based in Seattle. I think, Cheryl, I'm the guy from Canada. I accidentally pinned Canada, and that sums up my geography knowledge, I guess.
Close enough.
Then I couldn't reset. All right. So I worked in I worked for WSO2, and I worked as an architect in Ballerina platform, and that's what I do in the weekdays, and in weekends I'm a husband, dad, and a hiker, and also I do wildlife and landscape photography as a hobby. So that's about me. So today's topic is about Ballerina and how you develop cloud native applications with Ballerina, what advantages you have when you start writing programs in Ballerina. So I have a few slides. I'm going to quickly run through them. Then I'm going to do what I do best, like coding, but a little bit different because it's live coding. So let's see how it goes. So I'll be building an application. Basically, you can call it REST API and HTTP, and that will communicate with two other services. And then let's see how it goes. So I'm going to deploy locally and run, and then I'll try to deploy that into Kubernetes. Let's say without writing a single line of YAML. So let's see how that goes. So that's the plan. Let's get started. So what is cloud native? Cloud native is a well-established term. I think we all are familiar with the meaning. It's pretty common these days. When you look at cloud native from the development perspective, what do you mean by cloud native? Do we provide the right abstractions to developers to write code and design applications that are meant to live in the cloud, right? I mean, do we see these abstractions in existing programming languages, existing frameworks, likewise? So that's mostly the topic of summary of the talk. I'll explain these abstractions later on. So cloud native development is more than just writing code. So in the old days, I think we all do that. We still do that in our local machines. We write code, compile it, run it locally in a physical machine. But we don't do that. We don't run production systems these days. That's very uncommon. So today, we write code collaboratively. Collaboratively, I mean, we build systems by communicating with other systems. So today you write an application, you more or less, you are communicating with a database or other systems over the network, like you'll be connecting to HTTP, GraphQL, gRPC, depending on the application. So all days, we write applications by linking libraries, using other software libraries. But more and more, we still do that, but more and more we are communicating with other systems over the net. So there are risks associated with that. And then we package that into a container, and then we write a little bit of YAML code, just enough to get deployed that into Kubernetes. And then we need to worry about auto-scaling. If we are developing an APIs, we need to worry about security, the API access, observability. Then there's a feedback loop. We look at the feedback and then we make necessary adjustments. And when we fine tune, we deploy minor version updates like that. So this is what we do today. And writing code is just one aspect of this, right? So it's an important aspect, but there's a lot more going on in today's world. So when we write code, we also need to think about programming languages, right? So we have low-level languages, we have high-level languages. So we differentiate based on they're abstractions. So you would use C, Rust, or assembly for certain kind of application, but you wouldn't use them for certain other kind of applications, right? So mostly enterprise applications, people use Java, C#, Go these days because of the abstractions. Like if you think of objects and their interactions, you can solve your problem using object orientation. And you usually think about, you model your idea using a sequence diagram. And then you have actors, then you have interactions with the other actors. That's how you think about the problem. But if you take a step back and look at the problems that we see today, if I'm writing an application, I need to connect to other systems. Does existing languages, or do existing languages have enough abstractions to work with? Do objects enough to write code? Right. So that's what I'm going to cover in Ballerina. So what do I mean by abstraction for cloud? Right. So cloud native applications, they are distributed systems. So what do you see them? What do you see in them? You have services and you have clients, right? So, and then services, they typically communicate with other services. It could be internal services. It could be external services via client. So the services can be like HTTP, GraphQL, gRPC, likewise. And then you need clients to communicate with other systems as well. Right. So this is the typical abstractions that you work with, that you need to work with when you think of a cloud native application. But do we see other languages or frameworks having these abstractions? Like, do you have an abstraction called service, abstraction called a client, an abstraction called network interactions? And then typically when you work with the distributed system, you need to think about these fallacies. And because network interactions, you can get errors. Like it's not like you are calling a local function. In a local function, you can pass correct arguments and you still get the correct results, like you get the output expected. But it's, even though you pass the correct parameters, correct arguments, you may not get the same result in a network interaction, right? So errors are there. And we are, as programmers, we need to think about the errors in these interactions, right? And typically there are other things here as well. Okay. So Ballerina is a language that we designed to address these cases. And also it's a language where you have a little bit more high-level abstractions. So that's what we think, but I'm going to show you that as well. And I'm here to talk about Ballerina and show what it's capable of. And it's up to you to decide whether it's good for your application or not. So I just took this slide, this screenshot from our website. So we recently released Ballerina Swan Lake, which is our production stable release. We did it early February. And I'll be using that version today. And then, so these are some of the technical features. I'm not going to go into them. And I'll try to cover some of them in my demo as well. I guess there's no better way to talk about a language than writing some code and show its syntax and semantics and try to build and see how it runs. So I'll just start with that. Okay, so in my demo, this is my plan actually. I'll be building a simple service. You could call it a REST API, an HTTP API. So the idea here is this COID CFR service. It will give you a list of countries with that country's case fatality rate. Like you can calculate that if you have number of deaths and number of cases, right? Then it's a percentage. So in addition to that, it will give you the income level region of that country, right? So to implement that, we need to communicate with this free COVID data API. I'll show you the URL. And also to get like income levels of a country, what region and other information, we need to communicate with the World Bank API. So the COVID data, you get a JSON response. World Bank, you could get a JSON, but their default nature is you get XML response. So let's see how we can work with JSON XML. And then we do some calculations, we prepare the response, and we send the response as JSON. So that's what I'm going to build. Let's see how it goes. Okay. All right, so this is VS Code. I'll be using VS Code throughout my demo. I have already installed Ballerina extension. And also I created a Ballerina project. You could do that via the bal command. So I'm just going to show the version that I'm using today. So it's a Swan Lake. All right. So this syntax, as you can see, it's familiar because we try to maintain the familiarity with other C style languages like C, Java, C++, C#, I would say, because that's important, right? So, but this is a simple hello world. It's good to start with a hello world, but it does nothing. So I'm going to delete this. So if we go back to the demo, so this, I'm building a service here. So I should start with the service. In Ballerina, a service is a first class construct in the language, right? It's a HTTP listener, port 9090. Let's take a moment to see what's going on here. So I just imported HTTP package. So similar to HTTP in the language, HTTP is part of the standard library. Similar to that, we have gRPC, we have, sorry about that. Yeah, we have gRPC, GraphQL, FTP, and many other protocols. They're all built into the standard library, which kind of makes sense for a language that is trying to address cloud native applications, because you'll be working with these protocols. Okay, I'll delete that import statement. Right. So this is a service, and let's say base path is CFR for the demo, like case fatal ratio. So I would like to expose two resources. For REST APIs, usually they are a collection of resources, right? Let me write down the resources here. Let's say CFR countries is the first resource. The second one is CFR countries, and then the code. You can get a single country information with the code, or you can get a list of countries. And perhaps you can configure, you can change the behavior of the resource, like via query parameters. Number of countries equal 10, for example. So how do you do that in Ballerina? A service can have one or more resources. We call them resource functions. An HTTP resource function has two items. First one is the verb. The second one is the resource. Here it's country. It's countries. And then the second one, let me add a second resource, because these are just get operations, right? I'm not working on the post or delete or patch operations here. Countries. And then let's model the path parameter. So you can use a variable here as a path parameter. Now, the query parameters can go as a parameters of a resource function. So this could be int number of countries. And if you do it like this way, then uses, this is a mandatory query parameter. We can make it optional by making the type of that optional. So this is an enable type in the language. There could be a value or this is essentially making an optional query parameter. All right, so let's take a moment here. So what I have done so far, created a HTTP service and added 2 resources. So HTTP is sort of resource oriented. You have verbs and resources. That's what I think that's what REST means here. But there can be like GraphQL is also similar. It's also resource oriented. So if you use the GraphQL listener here, you would use query and mutate verbs. But then there are other protocols like gRPC, which is sort of RPC, like they are method oriented. So in that case, the services allow remote functions. They're like get countries. So service allows both style of resource functions and remote functions. I'll delete this. This is not allowed in HTTP. Now the next task is to figure out a return. What do these resources return? So we can simply return JSON. That works. But the problem here is, as you can see, JSON is a native type in the language, just like int and string. It's built into the language, so you can write a JSON literal. You can navigate the JSON values pretty natively. But I don't think JSON is a valid answer here, because if you are generating an open API description, then you don't give enough information to that description here, because we need to know about the fields of this JSON response and the types, right? So our recommendation is to model the response as a record in the language. Let's say country. So, and we could return country code, name. Let me copy the rest in the interest of time. These are the other fields, right? So the response will be sending population, region, income level, and the case failure ratio. So I'll be using this country record as the payload. I'm sending an array of countries here, whereas in this case, I am returning a country. So you get an error because we are not returning anything at the moment. So this is sort of the skeleton of my service. Now with this skeleton, it's enough. Now this is enough to generate open API contract and share with your clients. So, and if you are not a person, I mean, if you don't want to write open API descriptions for your interfaces, you can just write some Ballerina code, you can fine tune the skeleton, and then you can generate anything out of it. So next, let's try to fill one of these resources. Obviously, we won't have time to implement both of them. So I'll start with the simple one. And once that is done, I'll copy the code. For now, I commented out the first one. Now, if I go back to the sequence diagram, we need to communicate with COVID data first, and then World Bank. So what I would need is an HTTP client, COVID data. It's a new URL. Let me get the URL from my notes. All right. And then, yeah, so this function, this initialization of the constructor can return errors. So the way we model errors in Ballerina, errors are explicit. We don't have exceptions in the language. So errors are another value, another type. So you can represent this behavior using a union type. So this expression will, if all goes well, you get a HTTP client. If there's an error, then you have an error. So this is how we model it. It's a little bit different from Go. In Go, you model errors as like multi-valued returns, I guess. And then you can filter out the error using sort of type checking using is expressions. And now inside this body, if body, the type of code data would be an error. And inside the else, now the type of that variable code data will be an HTTP client. So we do sort of type narrowing here. So this is good if you want to handle each and every error, but sometimes we don't do that in applications. We just pass the errors to the caller so that caller can come up with the proper error message for all other errors. So in that case, I'm going to just pass the error back to the caller. So I'm going to use check expressions. So check will take care of the error. So if an error occurs, the check will return the error from the function. Right. So I need to mark that this function is returning an error as well. Okay, so you get this yellow squiggly because the variable is unused variable. That's fine. So let's get some data from the COVID API. I can do a get call. And as far as I remember, this is the countries / I need to pass the code. Here I'm using a string template code. So I get some data. I can assign this to JSON pretty easily, but I want to process it. I want to process this data. I want to extract some fields and work with them, basic cases and dates, and calculate the ratio. So here again, I want to use a application defined type. I'll show you what that means. So first, let me look at a sample JSON payload of this API. I'm going to do a quick curl here. Countries, let's say GBR, and then let's format it using JQ. Okay, so this is a payload that I get from the COVID data, right? So I need to generate a record. I need to create a record to hold this data. So what I'm going to do here is we have this little utility in our extension where you can, when you give a JSON, it will create a record. Sorry. I'll just click on this. Now it generated the record definition based on the JSON. So, but I don't want all these features. So I'm going to make it as COVID data, COVID country, and there are a lot more details that I don't need. I'm going to delete all that. Keep population, good, and then I keep country info. I need deaths. Looks good. So I kept few fields, and here is country. This is country info, and I don't need all this information. So I essentially got rid of like fields that I don't need to work with. So you can do that in Ballerina because this record, if you notice the difference between this record and this record, we call this one is an open record. When you get a JSON, when you try to convert a JSON to the record, that JSON can have extra fields, but it has to have these fields. So that's the definition of open record. Sometimes it's easier to work with open records because you don't have to mention everything. This is closed, which means when you are defining this value of this record, you need to have all these, nothing else. So that is sort of strict. It kind of makes sense because here we are sending data. I'm using this closed record to send data from my resource, which I have control over. But here I'm getting data from external system, and I don't have control over the fields and etc. But what I want is these fields. If I have these fields, I'm good. I don't care about the other fields. So that's the philosophy here. Okay, so I have a COVID country. So what I'm going to do is, and I have always also noticed that sometimes you get this value, sometimes you don't get a value. So I'm going to quickly make it optional as well, so that otherwise it will fail because this field is mandatory. If I do it like this, I can make it optional. Now I'm going to use COVID country here, and that's going to be my payload, right? So what do we? Okay, what do we have here is this, I'm calling a COVID data client, do a GET request. It will give me a JSON. And now the JSON is automatically transferred to a record. It happens underneath. I mean, as a programmer, you don't have to marshal that. It happens as it's built into the language. Okay, now I think I have information to generate, basically calculate case fatal ratio. I'm gonna get in, let's create a quick function, cases, and the returns a decimal. Let me create a expression bodied function to do that. So how we do that is depths over cases into 100. So I think we get an error because these are integers, but the return is decimal. We don't do the automatic numeric conversion in the language. So it has to be explicit conversion. Okay. So we have a way to get the case fail ratio now. Okay. Now I'm going to do a little bit of destructuring to get the details out of this COVID country. Its values are here. Its fields are here. So I'm going to define something as country. I'm going to give it a name because I want to rename country as name here. So name will be a variable. Then cases. Let me copy that over. So if your variable name and the field name is same, you don't have to repeat it. So it's easy in that way when you're destructuring a record value into a set of variables. So this works okay. I think this is payload. All right. So next, let's do case fatality ratio. I do a CFR. We do deaths, cases, all good. Now, the first part of the problem is good. If you go back now, I need to communicate with World Bank and get the data done, get the additional data. So I'll copy that code over. So in the interest of time. Now, what I'm doing here is I create a new client to communicate with the World Bank API, and I do a GET request. And what I get back is an XML payload this time, right? So XML, as like similar to JSON, XML is also built in. Now, if I quickly go back to the console, just to show you the payload, I do a curl, country, GPR. Okay, it's XML payload. You have a country element. In that country element, you have income level element and region element. So what I want is to extract these text income levels, right? So let's keep this payload here. So I wrote a function to do that, and I'll copy it over here. So this function, when you give the World Bank payload, it will return a tuple with the first element is income level string, second one is the region. So what I do is, as I said earlier, XML is native. So you define XML namespace, then you do a little bit of navigation, sort of querying the XML value, and the syntax is native. Then you get the native, you get the XML element, income level, and the region. Then you extract strings. So here I could do income level and I guess income level region, and then call extract and bypassing the WP payload. So here I return a tuple and I destructure the tuple into variables. So it's easy to work with that. Then let me return. So here I'm going to create a country value. So this is a record. So this is going to be a record literal. So let me close this. This is the country. So I have a code already. I can do it here. Then I have the name, created variable here. And similarly, I have population, now I have region, income level, and case ratio. I think, so the way, I mean, I didn't explain that. You could write like this. So typically you record value is, this is a field name and this is a value, right? But in here, if the field name and the variable name is equal, then you can simply have something like this, and it's less characters. So I think this is okay. Now let me run this. In my terminal, you could run the command bal run that will compile, build executable, and run, like go run. Or you could use bal build that will create the executable, and then you can run the executable. I'll split the screen so that I can run a curl command here. Curl, it's localhost port 9090, and let me check. The base path is CFR. So it's CFR, it's countries, and the country code, GBR. And then let me, sorry, I think I forgot to format it. Yeah, so now we got data from multiple services, and we quickly come up with a new record value that has the case failed ratio, and then the income levels and population. So one last job, let me copy this other resource here. I think I don't have time to write it. So here, I have added additional query parameters to set the population, minimum death, minimum cases. So what I'm going to do is first call the get countries API in COVID data. I get a list of countries this time. Then I filter that countries based on certain criteria. I get a filtered countries. Then I go through the filtered countries and I communicate with the World Bank, get additional data, then create a new record value and push it to this country array, and they return the country array. So the data processing, the syntax is pretty similar to C# link, where you have a SQL-like declarative way of processing data, right? So you have this where, closes, let, define new variables in the middle. You can sort based on the case fatality ratio, and then you get the top n. Default value is 10. If user has provided, then it's top n in that case. So I'll quickly show that as well. I'll run. Here in this case, I can do countries. I should get 10 countries, I assume. You see, it's running. Is it running? Okay. Okay, I got 10 countries now. I think the first one is the country having the highest ratio. This is based on the data that I received just now. And then these other countries, and you can see population, income level, and then compare with the case fatality ratio. Okay, and you can play with it. So this is the idea. Now, that's all good. I think I have 2 more points. I'll quickly make them and I'm done. So I wrote the code in a hurry. I just want to show the capabilities of the language. I wrote a service and then I communicate with other systems. Now I started this with a sequence diagram, right? This is just to, this is my mental model of the program. Now the Ballerina as a language is designed to maintain the source diagram duality. Like no matter how you write the code, Ballerina can the code syntax and the semantics can always give you a picture. And it has 2 syntaxes, we would say. We have like text syntax, we have a graphical syntax. So the graphical syntax is based on sequence diagrams. So I will show the sequence diagram now. Here. So if we collapse everything, this is my program. I have records here, and I have functions, and this is my service. So in my service, let me move it here. In my service, I have 2 resources: get countries, get and country by code. And I open this one you can see the sequence diagram of this code. This is what I wrote using code. And no matter how I change the code, you always get the sequence diagram. So here's the COVID data API. I do a call, and then I do some processing, and I do World Bank API in a for loop, right? So let's say I can add a if here, for example. This is all free and open source. In Ballerina VS Code plugin, I can use an if here. It's a simple true. Let me save it. And then you can see the added if else here. And then now if I go to the code, I can see the if else added. So, and I can also quickly get this and do COVID countries new, I would say. Yeah. So then when you look at the diagram now, you can see that there's a new call goes to COVID data inside the if. Right? So the source diagram duality is one of the key design principles in the language. We can do that because we know what are the local function, local method calls versus what are the network calls. If you know, I think I didn't mention that. This is the COVID data client, and I do an arrow syntax here because this is syntactically we differentiate from remote calls versus local calls. Right. So because of these syntactic differences, we can do the diagram. We can do the sequence diagram. So next point that I want to make is I want to just generate enough YAML to deploy this into Kubernetes. Right. So that's my last. I'll take 1 more minute to do that, and then I'm done. So because of this abstraction in the language, services, clients, and the types, the port, listeners, everything, you can let me close all these, close the service. We have this feature called code to cloud. So when you do a build, you compile and build the code. But if you pass like this cloud equals build option, then we can generate the necessary descriptors for that cloud. It could be Docker or it could be Kubernetes. Let me use Kubernetes here. I'm running Rancher desktop in my, I'll just generate the YAML files and I'll stop. Because running is, then it's pretty straightforward. So here we compile the code, we generate execute. Now we are generating unable to build Docker. Anyway, my Kubernetes is running. Okay, one last step in the live demo. Anyway, so the idea is you can, this will, if all goes well, this will, you will get the generated Kubernetes. I don't think we have it here. We have the Docker file at least. We have the Docker file and the Kubernetes step failed for some reason. So this is a generated Docker file. I would love to show the Docker, the generated Kubernetes file, maybe some other time. All right, so that's a little bit about Ballerina. And Cheryl, thank you for having us today. Please, you can follow the Ballerina Lang Twitter handle. We have a Slack if you want to know more about Ballerina.
Thank you so much, Sameera. I was just going to say, oh, the demo is going so well. And then just that one last step.
Yeah, I've been running Rancher desktop maybe for a few days, maybe. Anyway.
Yeah, no worries. No, I really enjoyed that demo, actually. I really thought very nicely constructed, very clear. So I enjoyed it. Sameera, thank you so much for presenting. I really like Ballerina personally. Very excited to see hopefully more adoption and more people using it in the future. You already said if people want to get in touch with you or the Ballerina team, then Twitter is the best way.
Yeah, that would be the best. Yeah.
Brilliant. Okay, thank you so much, Sameera. And thank you to our other speakers this evening, Adelina, Andy, and Arick. I want to say thank you as well to the sponsors for tonight's meetup. And if you want to come and join us on a future event, then please do so. You can go to cloudnativelund.com. Our next speaking slots are in July. You can also sponsor our events or promote your own events if you want to. That is it from us for tonight, and that is it from me, Cheryl. Once again, thank you so much for joining Cloud Native London Meetup. I hope you enjoyed it. I'll see you again in April. Take care. Have a good night. Bye.